This third example is going to be slightly different than the first two. And the reason why is you can see that this parabola does not touch the x-axis. What does that mean? So we're going to solve this equation, y equals negative times the quantity x minus 10, quantity squared, minus 9. And we're going to assume that y is 0. Why would we do that? Because all x-intercepts have a y-coordinate of 0. Whenever you touch the x-axis, like if I put a point here, that would be 16, 0. It's sitting on the x-axis. I'm not going up or down. The y value is 0. Now let's solve this now that we know why we're assuming that y is 0. I'm going to add 9 to both sides because negative 9 and positive 9, subtracting 9 and adding 9 are inverses. That's my first step. 0 plus 9 is 9, and then negative x minus 10 quantity squared. I am not going to distribute the negative 1 in front of this quantity because distribution is not an inverse. I am not going to distribute or apply this exponent. There's no such thing as distribution of an exponent. And I don't want to apply this by multiplying this times itself. That's not an inverse either. This is really a negative 1 multiplied by this quantity. The inverse of multiplication is division. So now I'm going to divide by negative 1. Positive 9 divided by negative 1 is negative 9, and a negative divided by negative is a positive. Now I have to do something about this power of 2. So I am going to apply the square root property. If I square root this side and I square root this side, this power and this square root will be inverses. But it says right here I have no solutions. Well, I have no solutions because this doesn't even touch the x-axis. My x-intercepts are my solutions. But why? What does that got to do with the symbolic process? Think about the square root of negative 9. What is 3 times 3? It's 9, not negative 9. What is negative 3 times negative 3? Well, a negative times a negative is a positive. That's also positive 9. Can I come up with a number multiplied by itself that makes negative 9 where I can get the square root? Well, some kids might say, well, what about a negative 3 and a positive 3? That makes negative 9. That's true, but these aren't the square root because I have to multiply a number times itself. Negative 3 and 3 are not the same thing. So this is impossible in our real number system. Eventually you'll learn about an imaginary number system, which doesn't mean that it's make-believe, but it's an extra number system that you'll learn about in Algebra 2. But for right now in Algebra 1, it's impossible to do square roots of negative numbers. And we're done with this example. Please go on to the next video.